Hello, good day everyone. Today I would like to show you that how to design a temperature control. So the learning outcomes for today, use a MAX 6675 driver to convert the analog data to the SPI digital data, and use a K-type thermocouple as a temperature sensor, and design a temperature control. Now we look at all these components that which are required uh, to set up in order we able to do the temperature control. So this is the Arduino UNO, this is the MAX 6675 and K-type thermocouple, variable resistor, relay driver, a breadboard, male-to-male jumper, and male-to-female jumper. Variable register actually is used to read the user data. What is the temperature is required to control. While the relay driver is to isolate between the low voltage of the Arduino UNO and the high voltage of the heater. Now, before we proceed to this lesson, please complete this two video in order you have a better understanding on how to read the temperatures from the K-type thermocouple, and also this video how to read the analog data from the variable register and convert into the digital data. Now, this is a pin assignment for this project, which we have a variable register from the center pin, which is connected to the pin of A0 from the Arduino pins. And then we have a MAX sensor 6675, the pin D0, which is connected to pin D8, CS, which is connected to D9, a clock, which is connected to D10. There are another two pins for the MAX 6675, which are the VDD and the ground pins. Now the relay drivers it has only three pins. One is VDD, another is ground, another is the signal pin. So we only need the signal pins to connect to the D12. Later we can see that it's a green color. Yeah, this is a completed circuit, the overall of the design temperature control. So this is to connect to the high voltage of 240 volt from the AC power. So this actually is a high power for heat generations. So connect to the normal port open, and the COM. Normal opens mean that under normal conditions is open, the heat will not going to generate. Yeah, this is a VDD pin. VDD pin, ground, and the signal. The green color from here. So this is a MAX 6625, and variable register. This is the center part, which is connected to A0. If the red color actually is a VCC, and the black color is a ground. Now, this is adjustable of the variable resistor as an indicator that tell that what is the user, the temperatures that he or she want to control. So you may go to views for this video for the better understanding of the temperatures control. This is the overall of the flowchart, how to control temperatures. Normally, before we write the programming, we better come out with a flowchart in order we are easy to write the program. When we're going to write the program, we normally refer to this flowchart and make our life much more easy. Now, basically, we come to the common sense, the common logical manner. How are we going to control the temperatures of the environment? Now, we assume it's at the start now. Okay, now, of course, normally we need to read the data from the user. Okay, what is the temperatures from the user that we want to control? After that, of course, data is required to store into the memory locations. And then after that, again, of course, we need to read the environment temperatures in order we can compare. Hey, is it now the environment temperatures is already fulfill the user? After that, when we come into here, there's another loop. We're going to use a while loop to do the continuings. Right? This loop will continuously to operate when what condition. After we read the user data and the temperatures data, we will compare the current temperatures data which is required by the user. So now, if the current environment temperature is it higher then the user data or not. If it's not, that means it will turn on the delay. Turn on meaning that the heater start to turn on already. Of course, we need to read the data from time to time in order to update the changing of the temperatures. So this loop will always to execute. All right, always will execute here, as long as the environment temperature is lower than the user data. So you can see here the D12 is always turned on. Once the environment data is already higher than the user data, yes, it's not fulfilled anymore. It will come out from here and turn off the pin D12, which cut off the heater. Now it will come back into here from the beginning. Again, when come back into the beginning, same thing, you read the user data and the temperatures data. Now actually the environment is still higher. It's still higher the user data. So we can see the flow actually is execute accordingly, which is turn off the pin number D12. You can see all this. So this is the overall of the control sequence that how to control the temperature. So we have this flowchart. We just write the programming according to this flowchart. Now there are section 1, section 2, and section 3. Section 1, section 2, as I mentioned before, please refer to the 2 videos in order you get familiar of these 2 functions. And then we need to combine section 1 and section 2, and then we're able to write the programming for this sections number 3. Now, we need to create an individual voice program. Okay, what's the meaning of individual voice program? This is actually the program from the section number 1, which is to read the pin for A0. Pin for A0. Now, I would like to declare this is likely to become a one individual voice program, and also the serial pin likely to another individual voice program. So this is how I'm assigned. Let's say that this is I assign the name as a read temperatures. So I need to bring this the whole set of program into this another voice functions. Next, this is to display the data through the serial port. So I define that the name of this operation is called display data. So this is a syntax format. How are we going to declare the individual voice program? So these two of the name actually is a changeable. All right, you can define or any name that you like, that you easy to make you understand in the future when you want to refer to. Maybe you ask, after we create the individual voice program, where we have to put this individual voice program? Actually, we can put before the setup, or also we can put in between the voice setup and also the voice loop, or after the voice loop. Also we can insert into the program. Now we can see from here, this is a program which is combined together. All right, so this is to read the temperatures from the user, and this is another which is to display the data. This is how we combine and to insert the individual voice program into the one single program. So we can see now when we want to execute for the read temperatures answer, so we just call the name of the voice from here. Now one more thing, we have to be careful on that. Before that, actually there's an integer here, but when we want to create an individual of the voice program, the defining of this integer, we must move up to the before the voice setup, in order the data is applicable for all the different voice functions. Because normally the data we're going to do the decision actually is in the voice loop. So we must declare at the beginning of the programming. Now section 1, again, this is the link for you to get a better understanding of this video. Yeah, this is section 1, yes, from the programming. Right, you can, this is section 2, another to read the temperatures data from the Max 6675. To get a better understanding, please refer to this YouTube. So you can see that here it's already declared for the individual voice program. So just call the name of the voice. Now, I already combine these two of the program, but here I already define again. I change to call user value so that it will be easy. This is also another is user value. You read the data from user. So these are the two functions. Now we're going to write the program according to the flowchart. So now when we start, you can see from here section number 1. Actually, it's telling us that we want to read the data from the user. So I just call the function, which is to read the data from the user. And this data we're going to store in this memory location called user value. Next, I want to read the data from the heater. So again, just call the function, read the temperature sensor. This is which is called the function to read the data from max 6675. Now, of course, the next we need to compare the current temperatures and the user data. So the data which are stored into these two memory locations are the temp value and the user value, as we can see from this program. So we can see now we are required to write the programming for this. So as long as this not fulfill fulfill the statement, the condition here. So the while loop here we're going to continuously to execute. So you can see here. You can see from as long as the environment of the temperature is lower than the user value. So this function will execute. Right, they keep running. So this one keep running. So now inside of this while loop, we're going to write a program according to here. Now we here the next is tells that we want to update the new data from the user data and the temperature data. So just call the function, and next to turn on the pins. Turn on the pins number D12 actually to turn on the heater. So you keep running. You can see from here. Now let's say the environment data already lower than is already higher than the user data. Now they will come out. Right, no more valid. You come out, turn off the pin number 2. Yes, exactly. This while loop will come out and turn off the G number 12, and you're back to the as usual. According to the chart. So I hope this program is helpful for you, and thank you for watching.